18.3 and 18.4 deal with reflections, translations, which kind of go together in 18.3, and then 18.4 is rotations. So you already have done plenty of reflecting. We did that before. And you also did it last year. Remember when we would plot points to be able to graph a parabola? And if you knew where the axis of symmetry was and you're able to plot a point, let's say, that was 2 units to the left of the axis of symmetry, then you knew that you could also plot a point that was 2 units to the right of the axis of symmetry with the same y coordinate, or the same height, so to speak. So you've done that there. Well, a translation is really I want you to think of it as sliding without turning. And for these notes here on this page too, if you want to print this page out, you can. It's not a whole lot to write, but if you prefer, you can do that, or you can write it out. It's up to you. Okay, so translation again, sliding without turning. And basically, that's the result of 2 successive reflections through parallel mirrors, okay, or parallel lines of reflection, or axes of symmetry, something along those lines. So we're not just going to reflect something once, but we're going to then take that, we're going to reflect it once, and then that first reflection, we're going to reflect that through a second line, okay? So we'll see what those look like. And then a rotation, I want you to think of like the motion of a wheel around a fixed axle. So think about, like when we did the Kaleidoscope project on Geometry Sketchpad. You know how like everything kind of turned around that center point? Or you might even, like if you're looking at cars with certain kinds of hubcaps, it's almost like things are moving around the center part of it, okay? So in a rotation, you're going to see that if you're reflecting across lines that intersect, okay? So if you're taking an object, you're reflecting again across one line, and then you're reflecting across a second line, and then even against, you keep working around, you're going to end up getting a rotation. Okay, and we're going to see what these are, but I just wanted to kind of describe them to you in words first. Okay, so let's take a look. So here, translations and rotations. A translation, reflect triangle ABC through L1 and then through L2. And notice L1 and L2 are parallel. Okay, so we are going to do this just like we did before in 18.1, 18.2. So how many key points would we need to reflect? Hopefully you said 3, points A, B, and C. Okay, so again, you want this L line 1 to be the perpendicular bisector of the segments where C and C prime are endpoints, B and B prime, A and A prime. Notice that these 2 parallel lines are not vertical, right? They're not completely up and down on the page. So you're not going to have your next figure, your next triangle, your first reflection be, at the same level here. It's going to be up. So you just got to be careful about that. So go ahead and try doing that. Okay, and I'm back now. So if I reflect that, I should have gotten something that's similar to that. Notice how B and B prime, or if you connect that segment there, this point right here would be the midpoint of that segment. Okay, notice how it's kind of slanting up because this would be perpendicular to our line. Okay, so then once you've done that, now you're going to reflect this triangle across L2, which is right here. Okay, so go ahead and do that. And hopefully when you did that, you're back. Now notice what happened here. Going from our original to our first reflection, the triangle kind of flipped over, right? But then it flips over again. We call that a vector. So it's basically like staying in the same orientation, but it's just shifting over a certain distance in a certain direction. You often hear of the word like vector. It's in the movie Airplane. There's a guy named Victor, and he goes vector, Victor, Victor, Vector. Anyway, if you haven't seen Airplane, I would highly suggest you see it at some point. It is quite not politically correct, though, so make sure you talk to your parents about it first. But it is pretty hilarious. Anyway, getting off topic there. But yeah, vector you often hear with like airplanes and so forth. So sliding in a certain direction, a certain distance. Okay. All right, so let's take a look at this figure. We have triangle HAR is a reflection of triangle BUC through L1. So HAR is a reflection of this. So this is our original through L1. And EST is the reflection of HAR through L2. Okay? And again, we have parallels. Notice what these spell, by the way. Bucharest. You know what Bucharest is? Look it up if you don't know. So you can see I've kind of labeled our vector, not really a straight line, but it would be this direction, this distance. Okay. Notice it's now, it's still same orientation. Okay, and the questions here are, which triangle is the translation image of triangle ABC for down here through L1, then L2. So here's ABC. You need to figure out which of these 1, 2, 3, 4 triangles is the translation image of ABC through L1 and then L2. So go ahead and try and do that. All right, well, hopefully you got triangle RTE, because we would go reflecting ABC through L1 would get us MPV, and then when I reflect MPV through L2, I'm going to be here at RTE. Okay, well, what if we were going to start with ABC again, but first we're going to reflect through L2 and then through L1? Which triangle would that be? Hopefully you said ZDQ, because we would be here reflecting this triangle across here. So we would be this distance, and that would be fog. And then when we reflect fog through L1, we're going to be that same distance over here. Okay? All right. Now, your turn. I want you to reflect triangle ABC through L1, then L2. And notice how B is actually a point that's right on our axis of symmetry, our line of reflection. Okay, so go ahead and try that. First L1, then L2. Go ahead and pause and then come back. Okay, so here's our first reflection. And then your second one would be to take this triangle and reflect it across L2. So hopefully you got that. Again, vector is this, right? It's that distance at that direction. All right, this one's a little bit more challenging, but this is what we call a rotation. So reflect the arrow through L1, then through L2. And when you do this, think about how many points you should have. So think about that, then I'll tell you kind of how many I think you should have. Okay, so I think you should have 1, 2, 3, 4, 5, definitely 7, and probably 8 or 9 points that you should have to reflect. Those being 1, 2, 3, 4, 5, just on the arrow, 6, 7 for the end of the tail. And then I would probably try to find a point like kind of on the curves. So you would want to reflect that. So if you did it correctly, that would look kind of like that. And then you need to go ahead and take this and reflect that through L2. Again, you're still going to need a lot of points, so go for it. Okay, and so there you can see mine, but you can see how these are all kind of rotating around this fixed center point. Okay, so that would be what we call a rotation. All right, and that's really it for the lesson. You're going to practice this more with your homework and the handout. So good luck and enjoy.